So now I'm going to show you how to actually wire up the robot, at least the motors, these Lego motors that will be used to drive the wheels. There are two motors with two wheels. Each one will drive a separate one. Before I show you anything, a very important warning about any time you use an Arduino and a motor. In every other Arduino project where you're hooking up the little circuits and such, you'll typically use the 5-volt output from one of the Arduino pins to provide power to whatever circuit element you've got. That is not the case for providing power to motors. You need a separate power supply. In this particular design, we've got 6 AA batteries down underneath here. Pop these back in. And the reason for that is twofold. Whoops, there we go. One is that the voltage required by a motor can be different than the 5 volts the Arduino supplies. In particular, the Lego motors want 9 volts, or if you're using rechargeable batteries, it'll be about 7.2. That's fine either way. But more importantly, motors draw a lot of power and a lot of current. And the Arduino pins are very low current, and if you try to drive a motor through them, at best it will probably permanently burn out one of the Arduino pins, and at worst it could burn out the Arduino chip itself. So you want to be really careful with that. So let me just show you what we're going to be wiring up. So ordinarily a Lego motor is connected to, a real Lego intelligent brick by one of these cables that looks like an old-fashioned phone cable, and one end plugs into the motor back here, and one end would plug into this part of the brick. Of course, there's no way to plug this thing into the Arduino. So what I've done is to strip those cables so that they reveal the 6 wires inside them and put pin connectors on the end. And there are 6 different colors of wire here. And of course, each one serves a different purpose. I've got one here where, so that I can keep track of them, I've actually labeled what each one is going to do. So the other thing I should note is that, as I've probably told you before, I like to use red for power and black for ground. And of course, Lego didn't follow that particular color scheme, so just keep that in mind when you're looking at the Lego wiring. So what you can see here, the red wire is actually the ground. The green wire is power for their, it's an optical encoder. It's going to tell us exactly how far the motor has turned. We'll not use it in this video, but we will later to give us more precise control of the motor. The white and black pins, wires, are motor 1 and motor 2. So what those are is really the drive for the motor. If one of them is high and the other one is low voltage, the motor turns in one direction, and if you swap the voltages, then it turns in the other direction. And these are the 2 wires that are going to need a high power input and not just the Arduino. And then there are these 2 things called tacho 0 and tacho 1 for tachometer. Those are the yellow and blue wires. And those are going to, again, tell us exactly how far the motor has turned to provide more precise control. We're not going to use them in this video, but we will later. So The first thing I always like to do when wiring up any circuit is to go ahead and connect all of my power rails to each other on the breadboard and all of the ground rails to each other and to the Arduino. When I'm doing this, I always leave the power to the Arduino not connected and, also not plugged in back here. And I'm also going to leave the actual 6-volt battery wire disconnected as well. So this one's the 9-volt battery, this one and this one are from the 6 AA battery pack. So I'm just going to run some wires to connect all of the red plus rails to the other red plus rails. I do this even, and by the way, I tend to like to use shorter wires for this, just so I don't have great big wires coming over. I've put a few of the shorter kind of wires in your kit. Feel free to use them or the regular ones. And the reason I always connect all of the rails, even if I'm not going to use them, or not planning to use them, is so that I don't forget to wire it up later if I suddenly decide I need to use it and am baffled as to why things aren't working. So here I've just got all of these pluses, the power rail together, and again all of the minuses together. And when possible, I try to do this sort of off to one end of the circuit board that, or breadboard that I'm not planning on using as much, just to keep wires out of my way. Here's one more. And now I am going, so even though the power for the motor, which is this 9 volts coming out of the 6 AA's, is going to be separate from the Arduino power and should never be connected to one of these rails that I'm going to use for the Arduino 5 volts. In any electrical circuit, anything with a ground, they all get connected to the same ground. So we'll just connect it to one of these rails. I'm going to run this wire up through one of these holes. That's just a better way to keep the wire from getting bumped. So I'll just plug this one in here. I'm going to leave the battery power just disconnected for the time being. I'm going to go ahead and again hook up the ground to the Arduino using any of the Arduino's ground pins. It doesn't matter which rail because the rails are all connected. And I will go ahead and connect the Arduino 5 volts over to one of my power rails. Again, they're all connected, so I don't have to worry about which one I'm plugging it into. Okay, so that's the easy part. This is the part we don't have to think about anymore. So now the question is, how am I going to wire up this? And again, I'm actually going to have 2 of them because I got 2 motors. And the first thing, or the next thing that you need to know is that we're going to need a little control chip called an L293D. You have one of them in your original Arduino kit, and you'll have another one in the extra robot kit I provided. Each one of these little chips can control 2 motors, and we're only using 2 motors now because we have 2 wheels. But we will someday want to probably use a 3rd motor to control any sort of powered attachments we might want to add to the robot, like a forklift or whatever. So one thing to note when you've got this chip is to figure out which end of the chip is which. And if you sort of look over here, you'll see that one end of the chip has a little divot in it, which is at the lower left of this chip here. There may or may not be a little circle there. There may or may not be a big circle here, depending on, exactly which model of this chip is. But it's this divot that really shows you which end is which. So I'm going to orient my chip with that little divot closer to the Arduino. It doesn't matter really, except we need to keep track of which end is which. And whenever you've got a chip like this, you're typically going to have it go across one of these little gaps in the circuit board to keep the two sides of the chip separate. And try to be a little careful when you're plugging this into the breadboard, so that you don't bend the pins. So here I'm just going to put this over here. Again, the little divot is here. And so what the heck are each of these pins for? So as I said, this is going to control two different motors. I've oriented this diagram, I've sort of highlighted that little divot is up here. So, boy, a lot of stuff going on here. First thing to note is there's this thing called VCC1 and VCC2. VCC1 is going to be the power coming from the Arduino, the regular 5-volt power. And VCC2 is the different, separate power source that's used for the motor. So that's the important one to keep separate. Again, I'm not going to plug in the battery power yet. I like to leave things powered down while I'm playing with wires, just so, the motor doesn't start doing something crazy, or I don't short something out if I connect the wrong thing before I've had a chance to check it. But I will go ahead and plug in that VCC1, the 5-volt Arduino, to the Arduino power. And again, I've just put it to the nearest plus power rail over here. All right, well, that's done. So now what are all of these other things? So GND, or their typo GMD, we're just going to connect these to ground, to our little ground rails. That'll be simple enough. And then the rest of this, each side of this chip will control one of the two motors. So if we look over here, the way this is going to work is the motor control really consists of two things, power and direction. So by providing more or less power on the signal, this enable line, that controls how fast things will turn. And then the other thing we will control is the direction, and that's going to be controlled by these inputs 1 and 2, and those are just going to, when one is high and one is low, we're saying forward, and when we swap those, it'll be in reverse. So let's go ahead and do that for one of these motors. I'll do the one that I've labeled first. And we need to plug it in down to the motor. And again, I like to try to run a cable through one of these holes just so that if things are getting bumped around, it doesn't affect anything. So I'm just going to feed this thing down through here and hopefully down through here and plug it into the motor. There we go. And then let's see. What have we got here? Let's go ahead and do the regular power and ground. Again, the green Lego, confusingly, is power. Just the regular 5-volt power, because this is going to the little circuit inside the motor that's going to help it count how far it's turned. In a regular Lego, it's actually 4.3 volts, but it turns out 5 volts works and is perfectly safe. The red wire, again, confusingly to me, is the ground wire, so I will carefully plug that into the black negative rail, not the tempting red positive rail. Okay, now I've got to figure out what to do with all these other things. So I've got motor 1 and motor 2. So motor 1 is the white, motor 2 is the black, and looking, if we're using this side, that's the output of this chip that we're going to need to drive the motor. So out 1 and out 2. So I will connect the white one, which is motor 1, to out 1, which is that third pin over here, 1, 2, 3. And I will connect the black pin, black wire from the motor, which is motor 2, to output 2 here, which is that third pin from the other end on the same side. Let me go ahead and connect all of those little ground wires. So sort of the two middle pins on each side. Actually, I'll move these because it's easier to do that. And again, I can actually connect it closer over here as long as we're in the same row. So I don't need these ground wires right up against the chip, just to keep the wires out of my way. Try to make sure that's sitting down in there. And I'll do the same thing for those ground pins on the other side of the chip. So it's the two middle ones, again going to the negative rail. Okay, and now what else have we got going on here? So better put that white one back where it belongs. So let's see. Now we've got the pins that are going to come in from the Arduino. And that's going to be, so we're going to need some pin on the Arduino for enable 1. And then we're going to need these two input pins. Those are going to be the ones that are driving the direction. So we can use pretty much any of our pins there. This enable needs to be what's called a PWM enabled one for pulse width modulation. It lets us give a variable amount of power essentially. So why don't we figure out some wires to use for that. Let's see, since we've got this white wire, which is the motor 1 output, let's pick a white wire for the motor 1 input. Again, colors don't really matter, but helps you keep track of things if things happen to be able to match. So we're going to need this white one here going over to one of the Arduino pins. I'm going to leave 2 and 3 unused for right now. I'll explain why in a little bit. So I'll connect this white wire over to pin 4. And let's see, since output 2 was black over here, well, again, I sort of hate using black for anything other than ground. I'm going to pick a dark purple just to maintain my sanity, or what is left of it. So that's going to be the second to the end pin over here, the one labeled input 2, and I'm going to hook that over to pin 5 there. Oof, actually that one's a little short. Okay, fine. I'll use a green because I've got a longer one. There. Fine. Green's going to pin 5. And I'm going to need something to go to this enable, which is going to control the speed. Let's see, maybe that purple will fit here. Let's see, pin 6. Yep, that works for me. Okay, so I've got all of the Arduino control signals connected up. So again, there's going to be 2 that are controlling direction, forward or reverse, and 1 that's controlling sort of the amount of power that's going. Again, this isn't actually providing the power. That's going to be coming from this VCC2, but it's providing a control signal that will tell this little chip how much power to send out over its output lines. All right, now I've got these confusing little taco 1 and 2 pins, and for now, let's just say they need to go to special pins on the Arduino that have something called an interrupt enable. Again, these are going to help us control the motor more precisely. And since these wires aren't going to stretch all the way over there, I'm just going to hook them up to any open spot on the breadboard. And then I'm going to connect those to pins 2 and 3. And again, pins 2 and 3 on the Mega board have this special interrupt ability that we'll eventually need to learn about. So I happen to have a long yellow wire, so I can use yellow to go over to the Arduino. So taco 1, I'll put over to pin 2. And then again, I'll do a blue to match this blue on taco 2. And I'll have that go over to pin 3. Okay, so our first motor is now completely wired up. And now we need to do the same thing on the other motor. So again, I'm going to take my other cable here. Let's see, try to feed the wires through here. If you have trouble putting this in through the big hole, well, we can try putting the other wires through. But I personally find it easier to try to get this one in. Going all the way down and plug that into the motor. And now we're going to go through the same process here. Let's see, going to remind myself, let's see, the greens are the regular Arduino 5 volts, so I'll plug this in here. The red, confusingly, is the ground, so I will plug it into the ground. And then let's see. So let's see, what are our next wires here? So white, again, on this motor is going to be motor 1. And so we are going to connect that. Again, this is the output to the motor, so I'm going to connect this to output 3 here. So that's the second from the end. Or I guess the third from the end. And then black, which is motor 2, is going to be this output number 4, third from the end over here. And again, I'm going to have these blue and yellow things. Again, these are separate from those other blue and yellow because it's a different motor. So we'll just stick those on some two separate free rows here on the breadboard. And again, those are going to have to go to 2 other special pins. on the Arduino. The other interrupt pins on the Arduino are 18, 19, 20, and 21. So we're gonna connect this other yellow taco 0 to, let's do pin 18 over here, and we'll connect our blue. Well, that wasn't right. I meant this yellow. Yep, got to double check our wiring, right? So here we go. The other blue will go to pin 19. Okay, so we've got that hooked up. See, so we've got all the wires to the motor and out from the motor hooked up over there. Now we need those same 3 control lines from the Arduino. So again, we're going to need this input. So this is going to be the one going to the white motor 1. So we'll see if we've got a white one over here. It's going to go from here. And gee, it's not going to reach all the way over there. So what am I going to do about that? Well, I will just make a little intermediate connection here to stick it somewhere on the breadboard. Of course, I could just find a longer wire, but what the heck, I'll do this because sometimes that's what you want to do. And so we've got our white one. I'm going to put that one in pin 17. Now let's see, we need the thing that goes from the black motor 2 line. Let's see, I'll try to be consistent. Again, I sort of switched that over to a dark purple. And so that is going to be our input 4 over here. So let's, right here. So we'll connect from there. Over to the next pin, which is 16. And the last one we need is going to be the enable, basically the amount of power, the thing that's going to control the speed down here. And so let's go ahead and, oh, you know what? I lied. I used a green last time. So wait a minute. Apparently I used this blue for the spray this dark purple for the enable. Well, that's not going to quite stretch. So again, I'm going to find just another open spot on a breadboard and jump it over here. To this very last thing. And oops, and that means for consistency I'm gonna move this over one to number 15. And now I will try to find a green, because I like being consistent. What can I say? And so that's going to go, what have we got here? It's going to be the motor 2 line, which is going to be this other input over here. So that's the second from the end. And that one's the one that is now going over here to pin 16. We'll get that in eventually. All right, well, there we go. I try to double check to make sure I haven't knocked any wires loose. And what have we got left? The only thing we've got left is going to be the power from the battery, the AA batteries there. So, and again, we need that one to go over here to VCC2. That's going to be the higher power one. So, again, I'm not going to connect this to any of the rails, which are all being used for 5 volts. And again, I'm going to sort of stretch things over by using a second wire. And I'm going to switch from red to orange just for the sake of not using red when it's a different power line. Okay, there we are. We've got it all wired up. Guess we better write some code, and then, of course, we'll be able to plug in the Arduino part. So we'll be back in a second and do some code.